Hi, dear children. So now we will do something on Newton's law later on so that I'll prepare some question because if we continue with that, you'll forget it a bit too soon. So we'll go to reflection to prove object distance is equal to image distance. In for layman's concept, your image is as far from the mirror as you are from the mirror, your image. This is proved from the two laws. The object, the image are on the same plane that we know. If we don't have on the same plane, we cannot do the experiment or so. And number two, the angle of incidence is equal to the angle of reflection. See here, this ray, the angle of incidence is 0, so it'll come back. So this one will be here. And this ray, the angle of incidence is I. It will be reflected, and I is equal to R. So this will come to meet at B. So this B is the image of A. B is the image of A. So let me just put it. This is a ball, so this should be also a ball. Okay, so ball. So now see, you need to know some parallel lines, alternative angle I is equal to this. So if you know that and then similar triangle, you can easily prove. You read this, see, you read this because this is I and this is R, they are equal. Alternate angle I is this is 90, this is R, so all are similar triangle. BC will be equal to CA. So we are standing in front of the mirror, the image is equally distant from the mirror. So this is 1. So now we'll come to refraction. Here, the sine of the angle of incidence bears a constant ratio to the sine of the angle of refraction, and that constant is called refractive index of that medium called mu. So this is glass, this is air all around, and this is glass. Angle of incidence is here, this is the ray, and then because this is rarer, this is denser, it will bend in this way, and this one will be parallel to this. If you draw the line, you see parallel. And the law is sine of the angle of incidence to the sine of the angle of refraction is a constant, and it is known as mu. Note, mu is to be written like this: mu of glass with respect to air, because we will also do what? Glass and air. This will be glass, this will be air. So glass, air, denser to rarer, but here rarer to denser. So mu of glass with respect to air, which is stated as mu of glass with respect to air, you understand, and be careful with that. Always remember this. In your class, sine of angle is not yet taught. This is trigonometry. So when trigonometry is not taught, we have to come to this. See? This is, we have to draw a circle with the radius OD, and then this is the angle of incidence, the incident ray, the refracted ray, and then this is I, this is R, and we drop DF perpendicular to the normal, we drop EG perpendicular to NON. And before that, let me tell you, my children, sine theta, here is a right angle triangle, here is a right angle triangle, angle B is a right angle, so sine theta, we said, don't say perpendicular, BC also perpendicular, AB, but you'll get confused, opposite side by hypotenuse. So sine theta is AB, by AC. So now see, after drawing the circle, what do you get? DF, and you get NE. So sine I is DF by OD. And you know what is OD? Radius of circle. Sine R is GE by OE. OE also radius. So here we finally come to sine I by sine R is df by OD divided by GE by OE. So df by R into R by GE. R, they get eliminated, so it is 1. So OD, OE, radius of circle. So these are the things. So finally, mu of class with respect to air is equal to df by EG. So you don't need to see in the sine table what is sine 30, what is sine 20, okay, sine 60, sine 50. That will be lengthy. So this circle is the best. You get all in linear. So next time we will continue with this, and my next topic will be the total internal reflection, where you will get the critical angle sin C relation with mu. Thank you.